Okay, so now that we talked about down here, we actually didn't talk about destroy. So after we change and tweak all the objects, we just call destroy. It's this generic method that comes from Unity, and it just says you pass in any type of game object and we'll just destroy it for you. It's more generic than that, but for us, we're just using it for game objects because it's a complicated thing and let Unity handle destroying it. And if you pass in a second parameter, it'll destroy it after that amount of time. So notice where we have created a reference. We created this game object. We have a reference to it. We manipulate it. And here at the last line of code, we say, hey, whatever this thing is we're referencing, whatever we're aware of, destroy this thing. Destroy this game object. What happens is reference is actually invalid anymore. But we don't use it anymore, so it doesn't matter. What happens is we come all the way to the top again. We move another frame. We move another small fraction of a second. And we start the update loop all over again. We check if there's user input. We do all this, and we create another object, and we tweak it. And since we're referencing that new object, we end up destroying that one again. And then we cycle through again. And notice that this temp geo is always pointing at a new object every time we're creating an object. So, I went over the serialized field. I went over the distances. So I'm allowed to, since I made these serialized fields, I'm allowed to tweak these in the inspector, right? I can tweak my distance and distance change and try to find what works for me. But since I kind of know the range of values that are acceptable, maybe we should kind of safety proof this or baby proof this a little bit more. Because what if somebody puts like a really big number in here and it doesn't really work as expected, or make this too close to the camera? There's ways to break this, right? But since we wrote the code, we kind of know how to work it or not, how to make it work or not. So we kind of already have a min and a max here that I designed with this thing moving backward and forward. And my safety values, I don't want this thing closer than 5, and I don't want it as far as 20. So we can do another macro called the range. And we can say, hey, I want the acceptable values between 5 and 20 for distance, and between 0 and 1 for distance changed. And if I save that, these numbers will turn into sliders. So you can still manipulate them and change them. And in fact, you'll see them be like updated if this distance change is moving them. I'm going to zero this out right now. I'm going to say, like, look, I'm painting at 15. And I can move this closer or farther away. And if I change distance change a little bit, you can actually see the values changing, moving along the slider. So sliders are really useful to expose numbers that people can tweak, like other developers, and put like some safety ranges on it, right? So that is the macro command range. And you can see the benefit of using sliders, but they're only usable for other developers. What if we wanted to be able to expose these variables out for the user to tweak? Well, now we can start to add a user interface. So we were used to going into GameObject 3D. Down here in UI, we have some more stuff, right? So for this class, I'll be covering the canvas, which will also create this event system. And then I'm going to create an image and a text, and I'm going to end on a slider. But there's others that we'll cover later on. So you need to start with a canvas. That's like the root, the top. It's necessary for it to be at the top of the user interface. Now, there's some differences here. Notice it's a rect transform, not a transform. So it's a rectangle transform. Because UIs are flat and they're meant to be only shown in the screen and they're not like out in the 3D world, we're only dealing with them as a rectangle. And notice as I zoom out, we now have this like really big rectangle off and way off to the side. It's not meant to like obscure what's happening in your your play area, your game world. And so if you go into game view, you'll be able to see stuff. You'll be able to cast it onto the screen, but it won't be like obscuring your world. And there's other components, but we don't need to be familiar with them right now. Notice that an event system was created. And here's what these components look like. And event systems are going to help us handle the UI. It's going to abstract a lot of code away from us, so we could just like get a UI functioning without getting bogged down in the details of it. Event systems, you can think of like, I was kind of talking about them earlier. They're super useful in object-oriented programming, and it's like when an event happens, like in this situation, the user is clicking a button or the user is dragging a slider. You never know when the event will happen, but at some point the event will happen, and it will like cast out the event. It will call the event, and you want to listen to it. You want to subscribe to it. Other methods want to know when that event happens. Other objects methods want to know when the user is dragging on the slider. And so they listen to the event and their methods get called. So this idea of events. So now we have our canvas, we have our event. So we have nothing on the canvas yet. So let's just put a UI image. And if I zoom out and if I look up, it looks really big, but it's really just an image that's on this little corner of our canvas. And if I go into game view, this is what the user sees. Notice that the canvas is shaped the same as the game view, is what the user sees, right? So we are like previewing what the user screen is like, but our little preview screen can change size based on how I'm dragging it. So notice as I'm dragging it and it's changing size, that it's kind of messing up my graphics. It's messing up the user interface. And user interfaces are really complicated to deal with because there's all these different monitor sizes and aspect ratios and different types of devices like cell phones and tablets and computer monitor screens. And you don't know what the user is actually going to be viewing your application in. So UIs have to handle that. They got to juggle all these different aspect ratios, and that's why this canvas system is going to be in this rect transform. It's going to be a little different because it's more about like pinning or anchoring things into position around the screen space. So you can preview different sizes, different styles of screen spaces, or even free aspects, like however big of a little viewing plane you want. But normally you're just going to want to do HD viewing. So one thing to note is that, okay, let's look at how to handle this. So this image, notice the rect transform, this thing is now active. And this is like our anchoring system. It is going to be super useful. So I'm going to say, okay, where is this image? Where do I want to move it? Let me move it out. Let me move the position X and Y because we're in rectangle space, or in screen space. And let me say, oh, this is meant to be on the left, but in the middle left. So, okay, I should anchor it. I should pin it to the left middle. So when I do that, notice it tries to stay on like the left middle area. And so for most of the time, you get good results. It's going to break eventually, but these are really extremes. Like when would this happen out in the real world? But you see most of the time it's pinned nicely. So that's nice. So you got a little image. That's great. Let's put some text in it. If you click that text for the first time, there might be a pop-up that says you have to import Text Mesh Pro. Just click import. It's a text package. It's just it's a third-party resource, came first-party, and it's just the way they handle it. All right. So text is in. It's got a rect transform. If we move down to the text component, you can enter a new text. Maybe I'll just type in like hello. And you can change the size and position and alignment and stuff. So let's say I want to move the text to be in the center of my box, right? So let's say I keep moving it and I'm trying to move it. So one thing I see is, oh, it's white on a white background. So maybe let me just change the color to black. for some reason the words fell off. That's because the width wasn't long enough. So if you just open up the width a little bit, hello fits into the little text box. And cool, let me say, oh yeah, great, I have hello in the box. But if I move it, notice it's not like staying with it. So not only is it needs to be aligned, but let's use our hierarchy to organize stuff better. So text is meant to be a part of this background image, right? So let's drag it underneath it. Let's parent it to it so that now it like inherits the transform. It inherits that anchor as well. So now it's staying there. Awesome. But now since it's centered up, so these numbers change as well. It's like, oh, you want it to be underneath this other object. Let's inherit some of its position information. So I could just zero this out now, and it will put me in the center of this image. So now it looks like it's at the top. So some of the things we have to look here is alignment. Let's center up horizontal, center up vertical. Now it's centered up in there. And you could, if you wanted to, you could change the size of it. But this looks good to me. And now since it's all centered up and it's a child of the image, it's inheriting the rect transform. We don't even need to pin it and stuff because it's just inheriting it. So that looks great. That's positioned well. So the last thing that we're going to add is a slider. So let's see. Let's move the slider a little bit, and it's just pin it. It's saying, okay, we're going to be in the bottom left. And as I move it, notice the slider sits well in the bottom left, and the text box sits well in the middle left, but they start to overlap a little bit. So when you start building out more elements in your UI, you might be like, okay, maybe the text box should be anchored up in the corner as well. Just maybe keep them clustered together so it looks a little bit better at the different screen resolutions. All right, so this is looking good. So now let's go into the slider component, and there's a bunch of stuff to look at. I'm really only interested in the min value, max value, and default value. So we have a min, we currently set 0 to 1, and as I move value, notice it's moving the slider in the scene, and notice the values being updated, and we're going from 0 to 1. Now notice if I update max to say 10, as we move this value now, it's going between 0 and 10. All right, now this slider is going to represent our distance that's allowed to place an object. So it defaults to 10, and it goes from 20 to 5. So range is 5 to 20, defaulting to 10. So since that's our code, that's what we figured out on experimentation, we should mirror that in our UI so that the UI, the user, is actually aligned with us and we won't have like value mishaps. All right. So min is 5, max is 20, default is 10. Looks like this. Great. So I can click play. And I can move the slider. You notice I'm like painting while I move the slider. That's okay. We'll change that later. But I'm moving the slider. And I can see here that it's actually updating correctly. But it's not, nothing's listening to it. It's not changing anything. It's not connecting to anything. So how do we make our script listen to it? Well, we're going to need a public method that the slider can call. That the slider events can say, hey, this is a listener. I'm going to call this method. So this is a public method that other objects, in this situation, the slider component, can call. It's not going to return anything. Here's the name of it. It's pretty descriptive. Here's the input. It's going to receive a float called change. This is what the user is changing the value to as they interact with the slider. So change comes in, and we can set our distance property to whatever change is. And so distance gets updated. And since distance gets updated based on changing the slider, ultimately our screen to world point, the distance that we figure out there, will change, and that's where we place our object. So how do we do that? Once we wrote out that public method, how do we connect it up? So on value changed. When this slider changes, yes, we wish to call a method. We say plus sign, and it says, okay, what is it that you wish to call? So first up is, which game object do you want to start looking up? Well, I have my script on the click detector game object. And it says, okay, which which component are we going to look into? Well, this is the component. If I click here, this component I want to go into. So this is the component I want to check. And anything that's under dynamic, yeah, there's a lot of static stuff. Just ignore that because these are like things that you could just override and send into. But this dynamic stuff, this is like actually my public methods. This is the stuff I've written out that says these are public methods. They receive floats. That's why they're dynamic floats. They can receive dynamic floats. And so I'm interested in calling the change distance method. So notice it's all connected up. And it's going to call this method on the component object here that sits on this game object. And that's why it's going to impact that distance property, which impacts where we paint. All right, so it looks like we're defaulting to, sorry, it should be 10 because that's what I set everything else to. No distance change, I want it to be 0. Let me just pause this and change it here so it stays that way. So it should be defaulting to 10 with 0. All right. And as I paint, now we're painting objects 10 units away from the camera. And as I move this, notice this value is updating. And now we're painting 14.2 units. And this is 20 units out. And this is 5 units out. And so we're moving this UI slider, which is calling that public method on our component object and updating that distance property, which ultimately is impacting how far out we're painting stuff. And this is the slider here. And you can see the slider value is changing. And when it's changing, it's calling this method here, which is residing here, which is impacting where we're painting. And these are all the spheres. These are all the game objects we're creating and being destroyed. Big list of stuff. And as they delete after 3 seconds, they all go away. Cool. So we will stop here and continue next week.